Okay, so so let's see here. What did we talk about last time? All right, so we reviewed how do human beings solve problems. We user memory, ask questions, repetition. We talked about the mapping. Every single programming language, 100% of them, has facilities to mimic these three things. So the programming language is not important. Okay, you learned Python before. Now we're learning Java. Next semester, you'll be doing more Java in terms of Android. You'll be doing C# in the programming language. The software engineering class. You'll be doing Scheme in another class. It's all the same. It's all the same. It'll feel difficult at first because you're kind of, like me. It took me, 15, 20 minutes to become fluent in Vietnamese. Okay, but now I'm good. Right. Yeah, our natural languages are far, far, far more difficult. So when you talk to people who are bilingual or trilingual or even more, I mean, that's really impressive because especially when they're operating out of languages that come from a different core language. So their whole thought process has to change. We're lucky as programmers. We don't have to go through that. Programming is programming. Once you know how to program and you happen to learn it in language X, going to language A, B, C, or Y, it's a pretty easy jump. Little syntax changes, but you're still going to say, oh, well, I need to remember something right now, so I'm going to need to create a variable. How do I create a variable in this language? I need to ask a question. How do I create an if statement? How do I ask a question in this language? I need to make a loop. I need to make a function. These are all things that will be common in every single programming language. Now you just need to figure out, how do I do that? What's the syntax for that in this language? And you'll notice over time that there's significantly more similarities than differences. Every now and then you'll get to a language that just looks a little funky, where it takes you a little bit longer to kind of get over the hump, but pretty quickly you start recognizing that the differences are, here's a curly brace instead of this, or this one uses an uppercase letter for strings, this one uses a lowercase s for strings, stuff like that, little things. All right, so we reviewed this slide, kind of our evolution of our languages and stuff like that, and kind of reference this idea that, especially in technology, but I think it goes across the board, that the people that come up with various technologies like to attach really cool, difficult sounding names to things to make you feel like they're smarter than they are. I mean, that's like that's academia for you. Ask any of your professors what their dissertation topic was for their PhD. And I guarantee it'll be at least 8 words. Okay. And you won't really know what their paper is even about after they tell you the title. So, I mean, it's like we just literally come up with things that make us sound smarter than we are. That's the whole thing. Yeah. So industry is the same way. We talked last time. We have all these different Ajax, jQuery, Angular, React, and you can add 50 more things onto that list. They're all just JavaScript libraries, just fancy names for JavaScript libraries, and they wanted to make them popular, so they gave them kind of a funny, catchy name, something like that. All right. Last semester, even though we had the same slide where we kind of have, in terms of modern programming, we're going to say C is kind of our oldest ancestor, even though C was not the first programming language. There's languages before C, but our languages today, all of them are, I don't know, I can't come up with one, but 99.9% of our languages today are extremely influenced by C. All right. And then depending on where you are in these lineage trees, Java is influenced by C++, which was influenced by C, C#, and Java are the same language, minus some uppercase letters here and there. So it's, and kind of told the story where, Microsoft tried to steal Java, got sued, came out with C# instead. Whatever. I mentioned a few minutes ago that every now and then you'll run into a language that's a little bit funkier looking. Objective-C is one of those. Once you get past the difference in syntax, you recognize it's actually the same. But Objective-C at first, because it uses a lot of square bracket things, and at some point, once we get into some Java stuff, I'll kind of show you an example of that. But at a glance, it looks more intimidating. But it's the same stuff. In fact, realistically, I would think that Objective-C would be a pretty good teaching language because it doesn't hide very much from you. But it's just not that practical because then you're only really prepared to write, well, today you'd be not prepared to write anything. Nobody writes in Objective-C anymore unless they're managing an older Mac or iPhone code base. If you're creating a newer application for the Mac or iPhone, you're using Swift, which looks like C# and Java. But yeah, so really it's a kind of a dinosaur language, relatively speaking, even though it was used heavily just 2 years ago. And then these are all kind of our webby languages, but they're still programming languages. Most of these guys are interpreted and loosely typed. What do I mean by interpreted and loosely typed? What does it mean for a language to be an interpreted language?
Interpreted at runtime.
Okay, so during runtime, they're figuring out what each line means so it's slower, right? So in our mind, we might say it's slower. Okay, and what about loosely typed? What does it mean for a language to be loosely typed?
Doesn't it specify the variables?
Okay, so it all involves variables when we want to store pieces of information, whether or not we have to label the container for what it's supposed to store, right? So a loosely typed language says you can just create a variable. You don't have to tell us what you're going to put in there. A strongly typed language says when you create a variable, you have to tell us what you're going to put in there. Now, right off the bat, you might say, well, that's kind of inconvenient, right? If you go to Target and you buy a big Tupperware container, you should be able to put whatever you want in there. You originally got it for tax documents, and you decided, well, I throw too many of those out, so now you just use it for shoes. Okay, we just flip flop like that, right? Flip flop. All right, so
One after another.
I need like the late shows where they have like the drummer. Yeah. I need the band that just plays the song. I need the sidekick guy too. I need both. Everything about me is loud. Everything about me is loud. So in any case, see, you're sitting closer than you usually do. So you're getting the initial sonic boom.
Yeah.
That's why I sit in the front of chapel. God sweeps through from the front to the back. I'm getting the full impact. Hey, he's out in the hall.
No, he's getting over loud.
Well, okay, fine. I'm not God. I get it. But I'm getting a 0.001 bigger boom than the backseaters. Rounded down, probably. Okay. So, loosely typed says that we don't have to declare what kind of value lives in there, and most interpreted languages are loosely typed languages. Kind of goes with the territory. Strongly typed says when we define a variable. So the idea about strongly typed versus loosely typed specifically involves our concept of how do we represent memory in these languages? How do we do variables in those languages? All right, so that's what that topic covers. So in a strongly typed language, we have to label a variable for what kind of value it's going to hold. And from that point forward, that's the type of value that will fit in that variable. You can't put anything else in there. Similarly, as opposed to interpreted languages, we have compiled languages, which we do the translation prior to runtime. So at runtime, they are considered faster. Again, our computers are really, really, really fast today. So slower versus faster is only realized under very specific circumstances. If you're playing video games, there wouldn't be any video games that would be written, well, what we would consider high-performance video games, there wouldn't be any of them written in an interpreted loosely typed language. They would all be written in compiled strongly typed languages because they're faster. All right. But one of those languages isn't necessarily better or worse than the other, and they all came from C. So they all have that similar ancestor or whatever. Okay. So, but maybe from our high level, we might say that loosely typed interpreted languages are relatively slower than compiled strongly typed languages. All right. So we kind of talked about these things: machine language versus low level versus high level. Humans like high level, computers like machine language. Rather than us kind of agreeing to live somewhere in the middle, humans said, well, we can technically write low level code, but we don't want to. So we'll just put it on the job of a compiler or an interpreter to take our high level code, which is closest to what we'll be comfortable with, even though most of you still find it difficult. You'll at least be happy that you're not having to type out zeros and ones. Could be worse, is the punchline. All right, so computers live here, humans live here. Here's our interpreted versus compiled. Talked about a compiler converts from that high-level language to a low-level language. That answers our question about humans like to operate here at the high level. Ultimately, we need to get our stuff down to machine language. So we have a compiler that converts from this level to this level. That's what the compiler does. So it's a tool that makes our life easier. Okay. Loosely type, strongly type, we just talked about that. So then we started talking about what are types. So in this class, we're going to be working with a strongly typed, mostly compiled language. We can think of it as a compiled language, Java. And what I mean by that is, let me just insert a slide here. Compiled languages, something like that. So let me just show you kind of maybe the life cycle of a truly compiled language versus something like Java or C# in the .NET world. All right, so a truly compiled language is pretty straightforward. So either C or C++. So let's take the language like C, since that's our top level ancestor. That guy runs through the C compiler, which the old Unix C compiler is called CC. If you're on Linux, it's called GCC, the GNU C compiler. But in any case, it's running through a compiler, and that compiler ultimately leads us to an executable that you double click and it runs. Now, technically, the compiler itself is just taking it down to the compiler portion of the program called GCC is taking it down to a low-level code, and then it gets linked and ultimately spits out an executable. So this is accurate for what that tool produces. All right. So that would be what I would consider to be a truly compiled language. Okay. Now let's take a language like C#. Even though it's a little bit newer than Java, they did improve upon a couple of things with Java. So the C# goes through whatever Microsoft C# compiler is called. Let's just call it the CSC. That's what I called it in the other class. So C# compiler. That then takes it down to something called Microsoft Intermediate Language, which is a low-level language. So this is still compiler converts from high-level to a low-level language. But then we have another conversion that takes place by something called the .NET Component Architecture that converts from missile code down to assembly language and ultimately an executable for that platform. All right, so both of these ultimately are producing an executable. I'll come back to this here in a second, but C# looks like this. I would consider C# to be a compiled language. Java goes through the Java compiler called javac, which produces Java bytecode, which then runs through a Java virtual machine and then is interpreted for the CPU. So it's kind of both compiled and interpreted. All right. So Java, relatively speaking, would be a slower language. It's slower because at runtime, this Java virtual machine, which is a program that emulates a computer, it's taking your Java bytecode and converting it into assembly language and executable code that runs directly on the CPU. So it's doing a lot of conversion even at runtime. It's not having to convert from high level to low level. It's actually converting from low level to low level. So we would call that faster than a truly interpreted language like Python. Mm-hmm. But there is an additional conversion there that's happening, additional slowdown that would make Java slower than C#. C#, the very first time you launch a C# application, it runs through the .NET Component Architecture and ultimately creates an exe for your computer that gets used from that point forward. So then it's always native. All right. So C, no argument, it's a compiled language. C#, it's a compiled language. Java, it's mostly a compiled language just during runtime so it can maintain its idea of platform independence. It actually runs inside of a virtual computer that does this low-level language to another low-level language mapping, which makes it a little bit slower. So if we just talk about Java for a second here, before I get back into the types. So we would say Java is high level. Java is general purpose. General purpose. It is strongly typed. If you had to pick one of the two categories, I would put it in the compiled category. All right. You'd have to make the argument on which aspect of it is interpreted for that interpreted side of it. But I'd call it a compiled language. High level, general purpose, strongly typed, compiled. Anything I'm missing? That's fine. Now, when Java first came out, its claim to fame was something called being loosely typed. I'm sorry, being platform independent. Okay, it's a platform independent language. Write once, run anywhere was the argument for Java. Back then, and this is kind of an interesting thing, you don't really hear people talk about this about Java anymore. But back in this day, you had most people using Windows, and then a significantly smaller percentage of folks using Mac, and then a really tiny percentage of folks using Linux. Well, you still had the Mac people screaming pretty loudly when an application would come out for Windows and not for the Mac. So there was almost this like fictitious sense that we needed a programming language that you could write an application for a computer once and it would run on both Mac and PC. Even though if you follow a business model, it didn't really matter that it didn't run on Mac at the end of the day. The additional overhead that it would take to write for both platforms compared to the additional money you get from the Mac folks, it just wasn't worth it. I mean, Microsoft ruled the desktop world, and they still do. So this idea of Java being platform independent was almost born out of a perceived necessity that didn't exist. Especially when you consider the people from the Macintosh side that were probably screaming the loudest were the gamers. Okay, they were the ones that like, well, why did game XYZ come out for Windows, but I have to wait either a year or two or forever for it to come out for Mac? They were the ones screaming the most. And in hindsight, we would never use Java to write games because it's relatively slow compared to like a C++ because there's a level of it that's interpreted. So I guess hindsight's kind of 2020. But, Java's initial claim to fame was it's platform independent, write once, run anywhere. It actually, that aspect of Java probably is what allowed it to survive as long as it did until it finally then became kind of popular again, because now we do have all sorts of different platforms that we'd like applications to run on, right? In the early days, we just had Windows versus Mac. And we didn't even care about the Linux people. They weren't going to use consumer or the company created applications anyways. Linux people always like, I'll just write my own, which is fine. So they weren't really worried about that. Or two commercial operating systems were Windows and Mac. So you always had very separate applications running on those two. For instance, forever, Microsoft Office wasn't available on the Mac. And then you had that famous Steve Jobs keynote thing where they had Bill Gates' face on the giant Jumbotron, like looking down at all the Apple people where they finally had to, be in partnership with Microsoft to bring Office over to the Mac. And that was like, giving into the dark side type thing. And that was pretty funny. So, in any case, some of Java's claims to fame weren't really all that important in the early days, but they ended up becoming important today. And actually, you could even argue that Java was a main reason why the company that founded it sort of failed and was easily acquired by Oracle. So the company that originally founded, what was the company that originally founded Java? They're called Oracle now. Well, Oracle acquired the company. Did you guys memorize all my notes from previous classes? You commit everything that comes out of my mouth to memory. All my Vietnamese stuff, everything. Okay, so 100%. Everything's gold.
I wouldn't have a memory like that though.
So, nobody.
I don't think I found it.
We did.
We did. I just don't remember the name.
Sun Microsystems.
Oh yeah.
In fact, when I showed you the documentation for Java initially, I said I always go to java.sun.com and it automatically maps me back to Oracle because I've been using that documentation forever. So I just use the old thing. In fact, Sun Microsystems, they created Java. They were the ones, and we definitely talked about it when we talked about Microsoft getting sued. We talked about it last class.
Yeah, we did.
See, I'm in a bad mood today already.
You are?
Golf course closed again today.
Really?
I mean, we get 1.5 feet of rain and they can't keep the grass dry. And my country club is right on the Milwaukee River. I don't get it. Get out there. I haven't played golf all week.
That's not normal.
It's terrible. No, I play every day. This is terrible. I've had to go for walks to get my exercise. You know how boring walking is?
Well, walking chasing a ball. That's what's fun.
No, because then you sound like soccer?
Not like if you walk playing golf. But I know you do.
Oh, no, I don't walk. I take a cart. But I hit multiple balls. So I usually play by myself. But you're right. I mean, there's not really a great argument against this, right? But I'm getting a reasonable core workout from the swing, I think.
Okay.
Yeah.
Okay.
Plus, every step I take is like 50 of your steps. Because you weigh like 30 pounds or something, right? Yeah.
A little more.
Yeah.
That's running up to you.
I weigh more than that. I'm really just too short. I get to 14 feet. I think I figured it out. It's actually like less than 10 feet tall. I'd be average weight.
I'm not willing to share heights.
All right. So anyway, Sun Microsystems. We just talked about it last class. They were the ones that came out with Java. In fact, on the stock market, their ticker symbol was Java. You know, like Apple's ticker symbol is AAPL. Microsoft is MSFT. So if you're investing in those companies, Sun Microsystems ticker symbol was Java. They were all in on this thing, right? Java was a big deal to them. Now, before that, Sun was really a hardware company. They created Sun workstations and they had their own architecture. They had a processor called the Spark chip, the Sun Spark chip here. Oh yeah, it was legit.
Do the systems that you guys have here for Sun Microsystems, do they still have the old Sun chips on them?
Who? What?
Well, there's a few of the old desktops in the lab, aren't there?
Those are running Intel though. Yeah, we have some. Look at this, like sodas and stuff. Why would this pop up for Sun Spark? I got a nice picture right here. Yeah, so that's one of their old processors. That's their company logo. So this is their Spark processor, which was a reduced instruction set processor, which we'll talk about in the 325 class. So I'm going to loop this back to something. All of you in here had 150, right? How many of you had Dr. Locklear for 150? Several of you? Okay. Rest had what, Dr. Wall?
Yeah.
Okay. I think he probably talks about the grand ideas of computer science. Talking about both of those classes. But Dr. Locklear really harps on it, right? Yeah, because that was his dissertation thing, dealing with the grand ideas of computer science, except they had a really funky, long, crazy name. So did mine. Mine was just like write a video game, but I had this, it's a Java-based implementation of a multi-user collaborative virtual environment for the implementation, and yeah, it was just just runs on, and always like I'm going to write a game engine for an MMO. That's what it was.
Really?
Yeah, I just wrote a game engine for an MMO, but I had to come up with this big long topic just so it sounded like sciencey. Yeah. They're all that way. But anyways, Dr. Locklear talks about the grand ideas of computer science, where you have these different pillars of computer science, right? And you take all these courses in our program, and those of you who had a bunch of courses with me, sometimes you hear me talking about the same topics in different courses, but sometimes from a little bit different angle. All these classes are all interrelated, whether we're dealing with artificial intelligence or database or computer programming or operating systems, computer organization. They have so many topics that are directly related to each other because every single one of them involves this central computer. And so we're learning about these things from all these different angles. So, for instance, in the 325 class in the next couple of weeks, we'll be talking about reduced instruction, so RISC processors versus open architecture processors like Intel, and talking about timing and stuff like that. Well, Sun was a reduced instruction set processor, just like the old PowerPC processors were for Macs. Well, what did Apple do? Apple converted to Intel. What did Sun do? Sun converted to Intel. So they all went to Intel. Does that mean reduced instruction sets died? No. In fact, there's probably more computers today running reduced instruction set processors than non-reduced instruction set processors. How many of you have a smartphone? Every one of you has an ARM processor in your smartphone. ARM processor, which is a reduced instruction set processor. Just a little bit ahead of its time. Where did it really come into play? When we needed to start saving power for battery life. That's when they kind of made their comeback. So it's always about timing, right? So Sun Microsystems kind of died for a couple different reasons. And this is my version of it, because I'm sure there's financials and stuff like that behind it that also add to this story. But at least from my perspective, one of the big reasons why they couldn't make it is they never figured out how to monetize Java. They never sold it. And this was back in a day when it was common for programming language suites to cost money. Like if you went and you wanted to use Microsoft languages before their .NET stuff, you would buy Microsoft Visual Studio. In fact, this is when Microsoft first released, announced C#. It was at University of Illinois in Urbana-Champaign at an ACM conference. And I was at this conference, and you always go to the Microsoft presentations, not because they were actually interesting, but they gave away the best stuff. And the other ones are giving away little bouncy balls with lights and stuff like that. Microsoft, they were giving away Visual Studio 6.0 Professional. It's like a $700 software package, sealed. Well, most of us had already pirated it. Don't do that, by the way. So we already had, completely legitimate copies of the software. So we just, this was the early days of eBay too. So we sold that thing on eBay for like $450 just for sitting through Microsoft C# talk. It's great. Yeah, it was so good, so unethical. Don't do that. This is the younger, stupider me. That was 2 weeks ago. So, in any case, this was back in the day where it was common for companies to charge money for programming tools. Mm-hmm. Sun Microsystems never did. Java was always free. They never really figured out how to monetize it. They also never really figured out how to integrate it. I think Microsoft's programming languages today are very good. So I don't want to, they're great, actually. But what's even better than the languages is their tool. Visual Studio is a highly, highly integrated tool. So no matter what kind of programmer you are, you can download this one product, Microsoft Visual Studio, and there's a free version and there's a paid version if you're working like in teams. So what you're really paying for is the collaboration tools to work with other people. You can get their full suite of language stuff for free. But everything is integrated together. You're a little bit forced into Microsoft's ecosystem. So like, hey, you want to use a database? Guess what database you're going to use? You're going to use Microsoft SQL Server. Why? Well, because Visual Studio will make it trivial for you to connect to it. So it makes sense for you to use it. It's not like it's a crappy database. SQL Server is fine, but your decision was removed. It was taken away from you because you have a tool now that makes all those things tightly integrated. It makes your life easier as a programmer. So you don't have to worry about setting up this connection. Where in the Java, well, still today, but if you want to have a Java program that talks to a database, you had to set up, this JDBC connection you had to pick what database you wanted to use, and you had to go and find the right plugin to have this JDBC connection to hook to the database for that. And then you had to write, 20 lines of code that actually established that connection. It wasn't trivial. It wasn't that hard. Once you did it 2 or 3 times, it was, you just copied the same code. But it wasn't just, a button that said use database and then all of a sudden it's connected magically. And now even more so with Microsoft and their cloud stuff, using Microsoft Azure. So cloud computing stuff with your project with Visual Studio is also trivial. You hit a button and now all of a sudden you have the Azure panel that drops down. You can start dragging and dropping Azure things into your project. So one of the things that Microsoft always did pretty well is integration. Their things all just worked well with their things. And that's what Apple's famous for too, right? If you're in the Apple ecosystem, all of a sudden, as long as you stay Apple, everything just works. One of the things I noticed, one of the biggest downsides of last year was the first year I switched. I was an iPhone user forever. And I switched to Android. I didn't like the fact that Apple was making me wait 2 months I get a new phone every year. And I didn't like the fact that I had to wait 2 months for the latest, greatest iPhone X or whatever. I write software for both. So my wife still has an iPhone. So I got a Note 8. Now I have the Note 9. But you don't think much of it. I'm a technology guy. Transition, no big deal, right? Using Android, not a huge issue. In fact, there's things I like better about it. But what do you think was the thing that had the biggest impact on me day one? I won't make you guess too long. Anybody have an initial guess?
Transferring your software?
No, that took no time.
The layout?
No, using the operating system worked fine.
iMessage.
iMessage. My whole family is on Apple stuff. So when we send messages to each other, it's the blue messages, right? Okay, that doesn't require you to be, that's not using text messaging, it's using data. Well, it's a bigger deal here on campus, and I still suffer from it today because you get a really crappy cell signal here on campus unless you're on Sprint. So I'm on AT&T, so I get between 0 and 0 bars on campus, which means I can't send or receive text messages most of the time. But if I had iMessage, I could, because that's using data. So I can send messages and receive messages. So I'll miss stuff now that I wouldn't have missed before. But there was this whole transition thing where I had to teach my mom how to text me by my phone number. Because she usually just click my picture. Send Mike a text. For her, there was no difference. But little things like that. If you stay in the Apple ecosystem, life was easy. The second you threw one little wrench in there, and it's fine now, other than the signal thing here, it's not the end of the world. But, because then, what do you use? You use another app as I think we use WhatsApp, my wife and I, as the backup. When I'm at school, she'll message me on there. So there's solutions, but there's an ecosystem thing there. So Apple's been very good at having everything within their ecosystem work. Microsoft's the same way. Sun Microsystems never did well with that. They were poor. In fact, you could argue they had more technologies, more individual kind of cool stuff than Microsoft had, certainly at the time. Maybe even compared to what Microsoft has today. But their individual Java products were never integrated together into a single thing. So you wanted to do something with Java servlets, you had to go and download the Tomcat web server, which supported Java servlets, and then configure your servlet container and all this other stuff. And then all of a sudden you want to use Java Beans, whole different thing. So you had to go and download a whole different development environment. You didn't just have Visual Studio that everything just works on. Okay. Even when they had their integrated product, they had an IDE called NetBeans. It still didn't really integrate stuff very well. So Java had these weaknesses, even though the underlying technology was a strong technology. And that, I think, certainly in part is what caused them to fall apart and make themselves acquirable by a company like Oracle. When there was a day when Sun Microsystems, consider this. I asked you what was the name of the company. How many of you before, well, let's say last class, but chances are probably the same answer for this class, hadn't heard of Sun Microsystems before?
I think I've heard the name once.
Probably in my class before. before I inserted the name Sun Microsystems into your brain, it's not a real common name for us today, right? It was one of the biggest companies in tech. Right up there with Microsoft and Apple, actually probably bigger than Apple at the time. Yeah. You know, they were a major player in servers. When I used to be, I taught at Western Illinois University. I also did system administration stuff over there. They were a Sun shop. All their servers were Sun systems, Sun Spark stations. I mean, these were a major player in technology. And now it's like they're a footnote somewhere. We don't even hear about them. This wasn't that long ago. And they were a major player in 2000.
2010, they ceased operation.
Yeah, now they're called Oracle, but they don't make computers anymore, I guess. I don't even know if that's true. They might still make computers. Nobody buys them, but they might still make them. But in any case, that's where Sun really kind of fell apart. But the argument I might make is they were a little bit ahead of their time with some of this platform independent stuff and things like that. Back in the day, the catalyst for this was really like, oh, well, the Macintosh people are screaming that they want the software at the same time as the Windows people get it. So maybe if we introduce a language that's focused on platform independence, people will adopt that language and all of a sudden create their applications using that language. Therefore, the applications will automatically be available for both platforms day one. And oh, by the way, the Linux people will get it too. All right, something along those lines. But it really wasn't important in reality back then, even though the Macintosh people were screaming about it. But today it's more important, isn't it? Today we have several different operating systems that are floating around. We have Windows, we have the Mac operating system, we have Linux, which still is relatively unimportant because they're a different kind of breed of user who uses Linux. But now you have Android, you have iOS, you have a couple of different, I mean, we see Android and iOS as the primary players here in the States, but you also have Windows Mobile. Over in China, you have 3 or 4 different operating systems that are also running on mobile devices. So now we have a much broader ecosystem of devices that are on different operating systems or different architectures, stuff like that. We're now having a single language that's platform independent kind of makes some sense. Also, when you think about your smartphones, you know, we all have lots of apps on our phones, right? Now, you might have several apps that are games. You know, and games are likely written with one of our modern game engines, so they're higher performance. You have to target a certain platform with those and stuff like that, unless it's kind of like an Angry Birds game isn't like a real CPU hog or something like that. But some of these games like Fortnite, for example, is now on Android. It's been on iOS for a little bit now, I think. That's going to push your system a little bit harder. That's not something they're writing in Java. But a majority of the apps that are on your smartphones are business apps, right? Mm-hmm. You got PayPal on there, or maybe you have your bank app on there, or you have your Facebook app on there. These are not video games. Things that could run on a virtual machine you maybe wouldn't notice. Something like that. In fact, how many of you are Android users in here? All right. So and we're going to be writing Android stuff in here, Android's core language is Java. So every one of your Android applications runs within a virtual machine. So it's already built in to be slower right off the bat because it's running inside of a virtual machine. The game engines have hooks right down to the metal, so they run directly on your GPU hardware and stuff like that to make them a little quicker. But in general, all your applications are running on a virtual machine on Android, and it's not significantly dissimilar on the Apple side of things. You know, their ecosystem is a little bit different, but the whole goal on mobile is saving battery life. Also security, right? Security's become a big deal today. It was less of a big deal back in the days when Java first came out. You know, virus protection was sort of kind of a thing, but you didn't have the people writing viruses to attack things like they do today. It certainly grew quickly as Microsoft became a bigger and bigger and bigger target. But now we're constantly worrying about people stealing our credit card information or identity theft and all this other things. So security has become a major, major deal. Well, virtual machines offer a lot of additional security with only giving up a little bit of performance. And given that our chips, even in our mobile devices, have gotten so fast, it's not that big of a deal, right? I mean, this thing has an 8-core processor in it. You know, if you have an iPhone X, it has a 6-core processor in it. And the 2 high-end processors that are in it are faster than any individual processor in this. So the iPhone X actually has even a faster processor than this guy. And this is the Note 9 that just came out.
Is it liquid cooled?
Yeah, this guy's liquid cooled.
What?
Yeah, this is a phone that has liquid cooling built into it. I think probably specifically for Fortnite. It does actually work. I was playing some game on here the other day for, I don't know, like an hour or something. And this thing was cold to the touch. Yeah, it was. And the battery life is ridiculous.
Mm-hmm.
The battery life on the Note 8 wasn't very good, but this thing has a 4,000 milliamp battery in it. You know, smaller battery than the Note 7s that were exploding on airplanes because of the large battery. So, you know, just kind of lay that here. This is the Note 9, the new one.
Okay, because I'm getting a new phone soon, and I'm not sure.
This has 8 gigs of RAM in it.
That's more than
8 gigs of RAM and a half a terabyte of built-in storage.
I see.
That's a phone.
And you can expand it.
Yeah, you can put another 512. So you can get a terabyte of storage on a phone.
Yeah.
These have become computers, right? They are computers. This is way faster than the desktop machines that were out when Java first came out. You know, by quite a bit, probably. So the point is now we have a much broader ecosystem of different devices that people are actually using. Even if we just look at the 2 big ones, right? iOS versus Android. You know, you ask any group of people, you're going to kind of have a half and half divide. That's your old Windows versus Mac, except it was Windows versus Mac. Now it's iOS versus Android. 2 pretty big user bases, and then you have some other user bases that are sprinkled around that are still better, still bigger than the Mac user base was back then. So now there's all sorts of advantages of having a language or having technologies that allow you to have something written once and go to both. Okay? Or at least not having to make a huge rewrite across. So some things to keep in mind that Java was almost a victim of its own forethought. You know, its idea was just 15 years too early. You know, we could say the same thing with AMD. For those of you, how many of you have built your own computers before? Okay, several of you. Intel or AMD?
Intel.
How many? Do we have any AMD people in here? Okay, so why AMD?
Cheaper.
Okay.
At least when I built mine, I should say. Now it's a little more.
If you look at market share of the 2, obviously Intel has a significantly higher market share today, right? And this is a conversation we'll have in much more depth in the 325 class. But once upon a time, AMD almost overtook Intel with the AMD 64 processors, but they failed miserably. It really set AMD back probably for a decade because they had 64-bit processors before you had 64-bit operating systems. And their feeling was that that they have the processor, the operating systems were coming imminently, you know, like in 6 months. So you can get your machine now that's 64-bit capable, can still run in 32-bit mode where you lose a little bit of performance, even more so than if you were just running a native 32-bit processor. So almost like this virtual machine argument, right? Not quite the same, but similar to that. But the 64-bit version of Windows never came. Or finally came actually fairly recently. I think it might have been Windows 10. That was the first OS that came out that was only available in 64.
It is, yeah.
I think Windows 7, you could choose 32 or 64. And even in the earlier days, so people who were trying to take advantage of the AMD 64 processors were the Linux people that could recompile their kernel for 64-bit. But now all of a sudden, you had an operating system that supported 64-bit, but none of your normal applications would run on that operating system. Web browsers weren't supported. The big drag on Windows was Flash. Flash support wasn't 64-bit, even though Flash has all but died at this point. But back then it was a big deal. So you had all these drags, but you had AMD, who probably had what would be considered an extremely strong chip had it come out today, and with today's architecture stuff. But they were 15 years ahead of the promise because it seemed like it was imminent. And it seemed to everybody that 64-bit was imminent. You just couldn't get all these different software makers on the same page to convert their internal applications over to 64-bit. So you didn't have, well, Chrome didn't exist, but Firefox wasn't converted. Flash wasn't converted. Most of the applications you would run, you had to run in 32-bit mode. Now your machine's slower than if you were just running a 32-bit version of the operating system and a 32-bit processor. Kind of get what I'm getting at?
Yeah.
So, great idea, wrong timing. That's the nature of that's how entrepreneurial stuff works, right? Mm-hmm. That's why Star Trek seemed so cool back then, but now the stuff that's on Star Trek looks far less impressive now because we've had it for a decade. Now we just need the transporter. Wouldn't that be so much better if we could just transport everywhere?
Doesn't the actual body, or doesn't the original body die though? Yet?
Well, I don't know. We haven't figured out yet, but possibly. Yeah, there might be some real reasons related to that why we don't have transportation yet. Because I think they've come up with ways to I don't know, like beaming a jelly bean or something between 2 points. But yeah, it might not be the same jelly bean as what you're getting at. Yeah, it's possible. Yeah, there might be some destruction in the middle. Yeah, but it would still be if we fast forward past that, we say, what if this existed? How lazy would we become? I mean, I'm already the guy who's chasing the white golf ball in the cart, right? Would I even need a cart if I could just teleport to my ball?
Probably.
Well, yeah, that's true. I need something to hold the clubs.
Oh,
at least the clubs have their own teleporter. And then you get to the ultimate level of laziness. Now it's one thing if you're going on vacation and you're going to teleport from here to New York. That's a huge benefit, right? Teleport from here to London. What's the shortest you teleport? Like you're in class here, and are you gonna teleport to the bathroom?
On the couch. Yeah, go back.
It's like, I need a soda. It's like the couch to the fridge and back. So you go into some guy's house. Like, why do you have teleporter pads all over here? So I've given up walking.
That's not a good thing.
It's already not a good thing. Isn't the whole thing? I mean, the epitome of it isn't the United States like the fattest country in the world?
Yeah.
Yeah. So I mean, really?
Yeah.
They're close. They're close to us. We have an influence. So it's part of our gravitational pull. Yeah. So we'll be the first ones to just teleport everywhere. Even when we're walking, we teleport per step. You see that in these video games where certain characters have teleportation. Like I see it in World of Warcraft, like warlocks, mages can blink. They have a teleportation ability. And you'll see them running through towns and just blink ahead, 20 feet every single time the spell comes up. You're saying you wouldn't do that?
Oh, yeah.
Just it was a walk. I could gain 3 seconds just teleporting 10 feet in front of me. See, one day you're going to remember back to this conversation. He called it. Yeah, well, and this has happened before. I mean, cryptocurrency is a huge thing right now, Bitcoin, all this stuff. I taught a class on cryptocurrency and Bitcoin back in 2006 here. So we were already doing that stuff, and you go back and watch the video. We were doing multi-$1,000 transactions during class. Not then. Then it was pennies. But if you look at the price of stuff today, because we were creating a voting system based on blockchain technology. So we were doing a single vote was 0.1 Bitcoin. You know, that's a 10% of a Bitcoin when it was at 20 grand. You know, and we're just doing these transactions like it's no big deal. I'm still friendly with a student who took that class, and every student had to create an account on a place called Coinbase, which still exists today. And they gave everybody, when you create an account on there, you got $10 worth of Bitcoin. And they've kept it today. I mean, I think it's like worth like $400. He just never changed his account. He's got $400 in Bitcoin just sitting there from signing up for a free account back then.
You didn't sell it when it went to 20 grand?
I think he still has it. Yeah.
Waiting for it to go to 200.
Yeah. So, I don't know. So, in any case, Java has become popular again today because our reliance on platform independence has come back. You know, those are benefits for us today. So now writing applications using Java, leveraging, and it's not even about the language Java. It's about the underlying technology of Java. Like I've continually argued, the language doesn't matter. You could take C#, and if you laid it on top of Java's platform independent architecture that's been around for a long time, tried and proven, secure, all this stuff, be fine. I mean, the syntax of Java is nothing amazingly special. It just happens to be the underlying technology has become very popular, and that's why it's, you know, one of the most popular languages out today. All right, so having said that, and given that all of our languages came, if we just look at this lineage, we had C, which was a procedural language. Then we had C++, which is an object-oriented language, so we can throw that here in. That was the thing that was missing. Java is object-oriented. So C++ was the object-oriented version of C. Java was the fix for C++ where they removed memory, they removed the direct access to memory that we used to have with C++ to kind of protect ourselves from ourselves. So this is where this guy kind of lives. Well, the types that Java supports are influenced by C++ and C. In fact, we might say strongly influenced. So these are the kinds of values that a variable can hold. We have two different types of types. We have primitive types and we have object types. So primitive types are built into the language, and they've really been around since C with little tiny changes we'll talk about here in a minute. We're 11:20, right?
Yeah.
Okay, good. Object types, there are a whole bunch of object types built into the language, but we also can then create our own object types, just like we did in Python, and we'll do that in here as well. So there's literally an infinite number of object types. Okay. Primitive type variables can only hold a value. That's the extent of their talents. So if we think about variables as our means of remembering things, that's how we do memory in our modern programming languages. A primitive type just gives us a container to hold a value. That's it. Where an object type can hold 0 or more values and perform functions if needed. So really, we can stuff a lot more stuff into an object type. It's not limited to holding just one value. It can hold several values, or we can choose to hold no values. You can have an object type that just has a whole bunch of functions that do things. Okay, but then it can have a whole bunch of functions associated with it and things like that. So it's a much more robust tool. That doesn't mean it's better. In fact, you might say in many cases it's actually a slower tool because it has to be so, there's a lot of structure to it. Where a primitive type is fairly simple. It just holds stuff. It doesn't have to do anything else. All right. So, you typically as a programmer, you will use a primitive type first if it's the right tool for the job, and only if you either need to write something more custom or if there's an object that exists that helps you better solve the problem, would you move to an object type. From a performance perspective, primitive types would be preferred. All right. So those are our different types of types. All right. So then I listed our primitive types And this list is from byte down to double would be the list of primitive types for C, for C#, for C++, for Java. Identical list. When we get down to Boolean, in C, anybody know how Booleans were represented in C? In C, we didn't actually have a Boolean type. They were represented as integers, just 0 or 1. It was an int. C++, it was represented as a Boolean, still zeros and ones, but we had a primitive name for it. It was bool, B-O-O-L, all caps, in C++. Java, it's Boolean spelled out, all lowercase. In C#, it's bool, all lowercase. Massive changes. Just, you actually almost wonder, why did they change it? Like, given that they just kept all the other ones the same. When they did Java or C#, especially Java versus C#, why did they shorten Boolean to bool? You could say maybe it made sense, a little bit less to type. But why waste their time? That's just throwing one more little tiny curveball from somebody who is coming from Java over to C#. And you keep typing Boolean over and over again, and Visual Studio screaming at you. And you just wonder why they did that.
Gotta be different.
So in any case, these are our types that are built into Java. So let's talk about each of these. And you probably had a slide similar to this last semester, but we're going to review it again because it wasn't since the beginning of last semester. So a byte stores signed whole numbers. A short holds signed whole numbers. An int holds signed whole numbers. A long holds signed whole numbers. Okay. Why do we need so many different ways of holding signed whole numbers? Well, first of all, what's a signed number?
Positive or negative?
Positive and negative. So this can hold numbers that are negative numbers or positive numbers. They're capable of holding both. All right. Now, as a human, we might say, well, why wouldn't just all variables, all numeric value types be able to hold positive and negative? Well, it's going to take a little bit more memory to hold the negative part of something. And if you're using that memory for the negative, you've then given up some of your magnitude, maximum size of the value. And that'll make some sense here in a second, but that's a trade-off. All right, so we have a whole bunch of ways of storing positive and negative whole numbers. Why do we need so many different ways of storing positive and negatively whole numbers?
Different size buckets for storage. They take up how long takes up more space than a byte.
Yep. So this is 1 byte in size, 8 bits. A short is 16 bits. An int is 32 bits. Here, I'm going to put this inside in terms of bits. So this is 8 bits or 1 byte. This is 16 bits or 2 bytes. This is 32 bits or 4 bytes. This is 64 bits or 8 bytes. Make sense? Mm-hmm. Now, given that we have these different size bits, that means under the hood are whole numbers, things that we think of as like 150 and 217. They're actually stored as a series of zeros and ones, binary stuff. All right, so an 8-bit number can hold a value between negative 128 to positive 127. A short can hold a value between negative 32,768 to positive 32,767. An int can hold negative 2 billion. It's like 2.1 billion. To positive 2.1 billion. And a long can hold plus or minus So let's just say negative. I think it's like 16 quintillion.
That sounds right.
To positive 16 quintillion. If you want the exact value, this is plus or minus 2, roughly plus or minus 2 to the 7th power. This is plus or minus 2 to the 15th power. This is plus or minus 2 to the 32nd power. And this is plus or minus 2 to the 31st power, rather. And this is plus or minus 2 to the 63rd power. We're using one of those bits for storing the sign. Okay, it's a little bit more complicated than that because they're actually stored in what's called 2's complement, which we'll talk about in 325. But for us in here, one bit is used to store the sign. The other, in the case of a 64-bit number, the other 63 bits are used to store the magnitude, the size of the value. That's the part. So 2 to the 63rd power gives you some gigantic number, 16 quintillion-ish. It's 9 quintillion? Are you sure about the quintillion part?
No,
It's 9 followed by a bunch of stuff.
it is 9 quintillion.
Is it quintillion? Ah. Yeah. All right. But in any case, a big number. Now, but keep in mind, this is not an infinite size number. So if you do have to deal with a value that is even larger than that, there are object types built into Java that allows you to deal with arbitrary size whole numbers at the cost of performance. Bigger the numbers you get, the slower it gets. Make sense? All right. But from our perspective in here, I'm never going to ask you, what's the smallest value that will fit in a short, for example. This is more information for us just to kind of know where things came from. In general, as a modern programmer, if you need to store a whole number, you will almost always use an int. That's kind of our go-to move. If that isn't quite big enough, you'll use a long. If that's not quite big enough, you'll move to one of the object types. You will almost never see a modern programmer use a short. You might see a modern programmer use a byte, but for a different reason. They're not using it for the size thing. They're using it because probably they're dealing with something like streaming video or something like that, and it just happens to be coming in bite-sized chunks. So a byte is a convenient data type to hold something that is the exact size of a byte. Make sense? So that's why they would choose that. So we can mostly say shorts are dead. Nobody's using them. All right. But if you do go and look at some old C or C++ code, you'll certainly see people use shorts. Why is that? Why did they come up with all these different ways of holding different size values?
Memory was expensive.
Yeah. So it gets back to our argument. Memory used to be really, really, really expensive. We didn't have space for the stuff. Whole different argument today. Go back and watch the lecture from last year for the details there. But as a programmer, we used to have to be careful how much space we were taking up to store a value. Today, we just don't care because we're lazy. It's like, I need to hold a 7, throw that in an int. It's like, well, that'll fit in a byte. Yeah, I don't care. And actually, our compilers today will actually compile it down to the smallest data type that will hold it for efficiency.
Oh, really?
Yeah. So we might even add that the job of a compiler today not only is to give us optimal low-level code, but it actually is to make bad programmers look better. It's probably a true statement to that. Because compilers keep getting better and better and better because what they're doing is they're taking this moving target. So if every one of us wrote a solution to a problem, we might have a bunch of solutions that all accurately solve the problem, but some solutions in the high-level language might be better or worse than another solution, right, in terms of efficiency. Most of the time we don't care because our computers are fast enough, but now you need a compiler that will take that solution and bring it down to an optimal solution relative to what you wrote. That doesn't mean that a compiler is going to take a really good solution that's accurate and a really inefficient solution that's accurate and produce the same low-level code. But the hope is it bridges the gap somewhat. It says, well, this is better than what you wrote. This works the same, and it's better than the crap you gave me that tactically worked. All right, so questions about byte short, ints, longs. So for us, we're going to use ints most of the time if we need to hold a whole number. a char. This guy is an unsigned whole number. It happens to be 16 bits in size. So when I say something is unsigned, what does that mean?
Doesn't have plus or minus.
Not capable of holding a plus or minus, which means we get the full 16-bit space. So this can hold 0 to 2 to the 16th power. All right. So this 0 to 65,535. Okay. Now, first of all, how are chars represented in computers? We're starting to see a pattern here that computers really like numbers, right? Zeros and ones almost always represent a numeric value. So now we have to come up with interesting ways of mapping those numeric values to things that are meaningful to humans. Like if I want to store the letter A, I'm not actually going to store the letter A. I'm going to store some numerical value that represents the letter A. Okay, so in Java, we use something called Unicode, the Unicode character set. In an older language like C++, we use something called the ASCII character set, American Standard Code for Information Interchange. I also won't ask you about that. And I don't know that Unicode stands for anything. I think it just means universal code. I don't think it's like, I mean, I guess it could just be a bunch of people's names or something like that. But in any case, the first 256 things on the Unicode character set is the ASCII character set. So Unicode is a superset of the ASCII character set. So the ASCII character set is 256 symbols, characters with numeric equivalents. So like a 0 is mapped to this character, a 1 is mapped to this character, a 2 is mapped to this character, so on and so forth. All right. Unicode, the first 256 are the same as ASCII. And you got stupid things that are like smiley faces and like playing cards and stuff like that, you know, because this came out in the early days of computing when we didn't necessarily think about graphical user interfaces and, hey, you're going to build a card game. We're going to have a picture of a card. Like, what are pictures? Well, we knew what pictures were, but not how we're going to represent them on a computer. So now it's like, here's a symbol that looks like a playing card, that kind of stuff. But then all of a sudden, you know, notice the ASCII stands for American Standard Code for Information Interchange. Then all of a sudden we realize, you know what, there's actually other languages in the world. Okay, I'm fluent in many of them, as we've discussed. Unicode doesn't support every language in the world, but supports many, 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 many languages in their character sets. All right, so you know, it's a much more universal thing, but at the cost of space. Because now every single character that you're going to store is going to be stored as 16 zeros and ones. So when I say it's a 16-bit value, it's going to take 16 zeros and ones of memory in order to store a representation for a single character, a letter, a question mark, whatever. Okay. Now today we have tons and tons of RAM. We don't care. You know, eventually we might start caring again. But now we're in the new mode of speed. Okay, these are things we'll talk about in the 325 class. But we're less concerned about size of RAM. Now we care about speed of. Even look at it with our hard drives, right? You buy a new laptop today. It's probably less common today because we pretty much moved away from mechanical drives now, and we mostly have solid state drives. But for a long time, you would say, oh, I can get a laptop with a 1 terabyte hard drive, or I can upgrade to a 256 gigabyte hard drive. So a quarter of the space is an upgrade. Well, because it was a solid state drive, which was much, much, much faster. Orders of magnitude faster. That is a legitimate upgrade. That's where you'll notice it the most, actually, is if you upgrade the hard drive like that. So in any case, we're in that mode now. How do we make what we have faster? And even at the cost of making it smaller, we don't care because smaller is relative. You know, most of us can get by on 256 gigs of storage. And then you just get the 2 or 3 terabyte external slow drive for just your mass storage stuff where you keep your photos and stuff like that. Things that you're not going to use. You know, you're not going to be double clicking to launch an application off of that. Just bucket storage. All right. So Our chars are unsigned whole numbers because we don't need negative numbers. So we can represent 65,536 unique characters. First 256, which are the same as the ASCII character set. So chars, even though we view them as letters and symbols and things like that, are actually represented numerically inside the computer. Computers like mathy stuff. Cool? Floats, kind of like ints, with decimal points. So it's 32 before the decimal point, 16 after the decimal point. 32 by 16. Doubles, kind of like longs, with decimal points. So this is 64 before, 32 after. So 96 bits makes up a double. And Booleans, these are true / false. Under the hood, these are zeros or ones. But we can't do math with them anymore. We used to be able to actually do math with Booleans because they truly were numeric types. Now they're not. Okay, questions, comments, concerns, bribes. Okay, make sure you get the book. You can go ahead and get Eclipse downloaded and run on your computer. If you want, you can go find like a Hello World example or something like that and just get it running. I think they even have a tutorial thing for that right with Eclipse just to make sure your setup is working. Remember, your Bible homework is up. It's due by midnight on Sunday, and I will see everybody on Tuesday. And hopefully we don't get any more rain and the golf course opens back up.
Okay, and you
Nope.
big ones.